A single drop of water hits sand, it vanishes. The grain barely shifts. Nothing visible happens. But beneath the surface, something extraordinary just occurred. A capillary bridge formed between two particles, and the friction holding them in place dropped by half. That droplet is the entire answer to one of history's oldest questions, and almost nobody knows it. Most people believe ancient civilizations moved massive stones through sheer brute force. Thousands of slaves, whips and chains, endless suffering under a merciless sun. It's the image Hollywood burned into your mind. It's also wrong. The largest stones ever shaped by human hands sit in Baalbek, Lebanon. 3 of them, the Trilithon, weigh roughly 800 tons each. They were lifted, transported, and placed into the foundation of the Temple of Jupiter with gaps so tight you cannot slide paper between them. Still sitting in the quarry nearby is the stone of the pregnant woman, 1,000 tons, never moved. And beneath that, discovered only recently, the Forgotten Stone, 1,650 tons, the weight of 10 blue whales stacked on top of each other. How do you move something like that without a diesel engine? The instinct is to say you can't. But that instinct comes from a specific kind of ignorance, the kind that assumes ancient people were less intelligent than us. They weren't. They were exactly as intelligent. They simply faced different constraints. And constraints, it turns out, are the mother of engineering. In 1977, French architect and archaeologist Jean-Pierre Adam published a study in the journal Syria that quietly dismantled decades of mystery. He analyzed the Trilithon stones in forensic detail, the lifting bosses still visible on their faces, the prepared paths in the quarry, the elevation difference between the quarry and the temple site. His conclusion was mechanical, not mystical. Capstans, compound pulleys, rollers, timber scaffolding, and one critical geographic advantage that almost everyone overlooks. The quarry sat higher than the temple. The stones didn't go up, they went down. Gravity wasn't the enemy, it was the engine. But Baalbek is only one piece of a much larger pattern. Let's go to Egypt, not to the pyramids. Everyone talks about the pyramids. Let's go to a tomb wall instead. Around 1880 BC, a nobleman named Jehutihotep had a painting made inside his burial chamber at Deir el-Bersha. It depicts 172 men hauling a colossal statue on a wooden sledge. Standard scene, expected iconography. Except for one detail that archaeologists dismissed for over a century as ceremonial decoration. A man standing at the front of the sledge is pouring liquid onto the sand. For generations, scholars assumed this was ritual, a symbolic offering, just water being wasted. Then in 2014, physicist Daniel Bohn at the University of Amsterdam decided to actually test it. His team built sledges. They dragged them across sand, dry sand piled up in front of the runners, creating resistance. But when they added a precise amount of water, not too much, not too little, the sand stiffened. The grains locked together through capillary bridges. The pile vanished. The pulling force dropped by 50%. What did that mean in practical terms? A job that required 172 men now required 86. Half the labor, half the rope, half the food and water to sustain the workforce. The man in the painting wasn't performing a ritual. He was performing physics, and the Egyptians had understood it for at least 4,000 years before anyone in a laboratory could explain why. Now cross the Pacific, Easter Island, the Moai, nearly 900 statues carved from volcanic rock. The largest erected one stands 10 meters tall and weighs over 80 tons. The common story says the islanders dragged them on log rollers, destroyed their forests in the process, and collapsed their own civilization. It's a neat parable about environmental destruction. It's also largely fiction. Archaeologists Carl Lipo and Terry Hunt spent years studying the statues that never made it to their platforms, the ones abandoned along the ancient roads. What they found was counterintuitive. The fallen Moai weren't random debris from failed transport. They had a pattern. Wide, D-shaped bases, a forward-leaning center of mass. These statues weren't designed to lie down on a sled. They were designed to stand up. So Lipo and Hunt tested something audacious. They built a replica, 4.35 tons, and attached 3 ropes. 2 teams pulled from the sides, rocking the statue forward in a controlled zigzag. One team held steady from behind. 18 people. That's all it took. The statue walked 100 meters in 40 minutes. The Rapa Nui people had been telling researchers for centuries that the statues walked to their platforms. Nobody listened. Why would they? It sounded like mythology. But the oral tradition was the engineering manual all along. There's a pattern here worth naming. We assume ancient builders had less because they had different tools, different materials, different constraints, but different is not less. In many cases, it's more elegant. Consider what Brandon Clifford discovered at MIT. Clifford is an architect at the university's Matter Design Lab, and he became obsessed with a simple question: what if the intelligence wasn't in the builder, but in the object itself? In 2019, his team designed massive concrete blocks with variable internal density. The center of mass was calibrated so precisely that these multi-ton objects could be tilted, rocked, and rolled into position by hand. No crane, no motor, no hydraulics. The geometry did the work. The object contained its own instructions for how to move it. He called the project walking assembly. And when you watch the footage, there's a strange familiarity to it. The rocking, the tilting, the rhythmic side-to-side motion. It looks exactly like a Moai walking down a dirt road on Easter Island. Ancient engineering rediscovered through modern physics. Not because we taught them something, because they had already solved it. So here is the uncomfortable truth that sits underneath all of this. The question, how did ancient people move 1,000-ton stones, contains a buried assumption. The assumption is that moving heavy things is inherently difficult, that it requires extraordinary explanation, that the default state of a massive object is immovable, but a 1,000-ton stone doesn't know it's heavy. Heaviness is a human experience. The stone only knows friction, gravity, and geometry. Change any one of those three variables and the stone moves. Wet the sand and friction drops by half. Position the quarry uphill and gravity becomes your engine. Shape the object around its center of mass and it walks itself. The ancient builders didn't perform miracles, they performed observations. They watched how things moved, they noticed what surfaces did under weight, they paid attention to water, to slopes, to the exact point where a tall object tips but doesn't fall. And then they organized large groups of people, not slaves but communities, motivated by shared belief and social purpose, to execute those observations at scale. The real question was never about the stones. It was about the coordination. Who decides to move a mountain? Who convinces 1,000 people to pull in the same direction, on the same rhythm, for the same goal? The physics was always solvable. The sociology, that was the hard part. We build skyscrapers now. We pour concrete from trucks. We lift steel beams with tower cranes powered by electricity, and we call this progress. But there's something buried in the foundations of Baalbek, in the roads of Easter Island, in the wet sand beneath a painted sledge. Something we've mostly forgotten. The material can carry its own solution. The object can contain its own movement. The ground beneath your feet can be turned from obstacle into instrument if you understand it deeply enough. We don't lack intelligence, we lack patience. We replaced observation with horsepower and called it advancement. A single drop of water hits sand, it vanishes, the grain barely shifts. But if you're paying attention, the way they were 4,000 years ago, that single drop just moved 1,000 tons.